So let me introduce you to just kind of the next couple stages of what's happening. So I have a rolling chassis, which works for the most part. I have had some problems with the steering just recently in doing some testing. So what it was this was the battery that ran the steering. And it had a plug on here, a high current plug. This was 6,000 milliamps. And I had a charger plugged in that would come on when you plug the rest of the machine in. And it would charge us back up again. The problem was I wasn't monitoring the voltage of this. I had no voltmeter on it. I had no, multimeter. I had no way of measuring how dead this battery was at any one time. So I left a key on a little while ago, and this battery went dead. And this is a lithium iron phosphate battery. So one of the things about these things is if they get too dead, they're hard to kind of kick back into life again. So often what you can do is you can get a 12-volt battery and you can hook it onto it, just kind of give it a boost. And I tried that and it bubbled up, and I think I destroyed this battery. Like, I've had it for a month and it's destroyed. So I need a better battery management system. So this was one for the steering. So what I've done is I've done some research, and I'm getting into the building battery packs out of the 18650s. This is a common thing people are doing for power these days, harvesting them from old laptops and kind of rechargeable lithium devices. These ones I believe came from a Segway scooter. I bought them off of eBay. I think I bought them from an eBay dealer who, I don't know, whatever, they may have had problems with or anything. But so I bought 120 of these cells. So each one of these looks like this. So it's an 18650. These are 2600 milliamp or 2.6 amp hour cells. So I bought a charger. I bought a four battery charger, and I'm charging them all up four at a time, and measuring what I did first is charge them all up to 3.6 volts, and then charging them from 3.6 to 4.2. I'm keeping track of how many milliamps it takes to do that. So these four are ready. I have to put them into the charge bin and take these ones here and start getting them charged, but all in good time. Because what I'm building is I'm building battery packs for all the new technology that's going on to it. So that's kind of why I'm here, is to explain the technology. So let's actually start with those battery packs. So the steering pack, like I said, this LiPoly battery is being replaced by lithium ion. So what I did is I took 15 of these and I put them in a 3x5 pack. So this is 3 series, 5 parallel, and put a battery monitoring system on the end. I believe this is a 50 amp BMS. So I can bring power into these at 50 amps. Each one of these batteries has a 10 amp maximum output. I don't think I'll ever need it for what I'm using this pack for, but the 50s, better too much than too little. I can use this for something else if I need to. But what this is going to do is it's going to run the steering going forward. So when I put this in, I'll be able to just hook the power wires to here, and it'll come out of the battery to go to the steering motor and come out of the charger to go back into here. And this board is going to control the voltage that goes in and out of here, and the amperage, of course, too. So this is going to keep track of how dead the battery is. I purchased this thing. This seems to be new. I've never seen this before. This is a really interesting little device. They call this a multimeter, but this is like a panel meter. So I'm going to mount this in the box for the steering. Okay, when I power it up, it's going to look at the voltage of the battery. It's going to look at a whole bunch of things. How many watts are being pulled out right now? It'd be good to know that information for the steering. But the thing I like about it is this. So this is a Hall effect ammeter built into this. So this can measure the electrons going in and out of the battery. So if I run the charging and the power in and power out power to it, I can see how many milliamps have come out of the battery, and I can charge it back up and put those milliamps back in. So all I need to do is plug it back in, and this BMS board down on this one will control when the battery is charged. So I don't have to worry about it so much. I can plug it in, and I don't want to leave it plugged in, but I can plug it in and forget about it. But if I want to monitor it, I can walk up to this meter here, and it'll tell me how many milliamps have come out of the battery and how many milliamps have gone back into the battery. So this is kind of battery management, or actually power management. One thing I like about this is these two contacts right here will run a relay. So if the voltage gets too low, I can have this shut the main relay off to the machines. Right now the key turns it on. Well, what I'll probably do is put this in series with the key. so that if the power is turned on and the battery goes, the steering battery goes dead, this will shut the power off to the steering before the battery goes too dead to charge back up again. So it has under voltage protection, over voltage protection, under current, over current. This is a pretty interesting device. I'm looking forward to kind of setting this up, and I'm really looking forward to using this relay part of this. I want to know, you know, it's going to keep everything in a very specific range for voltage. Right now, with just running off batteries, you know, the whole thing runs differently when the batteries are charged or when they're empty. So I'm going to have this running a normally open, normally closed relay. So the relay, the normally open side will be closed when you turn the key on and when the voltage is enough. When the voltage dies, or when the voltage gets below its cutoff, it's going to do two things. It's going to cut the power, and it's going to turn. I'm going to put one of these red LEDs in on the surface of the box, the power box, and so I'll be able to see kind of from a distance when the steering stops. If this light comes on, that means because the battery is under voltage. So I got a bunch of these things. I'm going to put them in different places, you know, just to monitor things. You know, maybe when I have a radio signal, and I guess I should have got some green ones as well, but red ones are easy to see, right? So I got a bunch of those to kind of just let me know what's happening. Because I have an Arduino and stuff in here, right? I can use Arduinos to make decisions, and if it doesn't like something, it turns its light bulbs on. So that's the power. That's the power for the steering part of it. I also am going to take these batteries, and I'm going to use them for the control side of it as well. So here I have kind of the main piece. This is the brain of it. This is what they call a Jetson Nano. This is kind of a Raspberry Pi on steroids. There's a full-on computer inside here, but it's more than just a computer. It's a computer with accelerated graphics and accelerated GPU and CPU. So this is a really fast, designed for doing kind of entry-level artificial intelligence, which is what I want to do. It'll do object recognition, it'll do voice recognition, it'll do object avoidance, it'll do all kinds of stuff through cameras, right? So I got the stereo cameras for this thing. I'm just kind of learning how this whole thing works. I'm wrapping my head around it. I need to get some of the mechanical stuff done first. But what I want to do is I want to mount this to the robot, or to this vehicle. But I want to make this modular. I want to put this and some of the sensors I have on some sort of platform, fully powered on its own, so that I can move it from vehicle to vehicle. Right? Maybe I just download a new set of code to it, pop it off of one, put it on Fred or something, and I can use this to control whatever I've got, you know, different styles, skid steer, Ackerman steering, that kind of stuff. So this is going to mount on top of a metal box, about 8 inches by 10 inches, aluminum box. And inside the box, there's going to be 2 battery packs this size. So this is 4 by 6. So this is going to be 14.1 volts, 14.4 volts. So this is going to be more than 12. But I want to, this pack I'm building, this box I'm building with a whole bunch of, I'm going to try to put 2 of these things in it. So this will be 14 volts and change times 2.5, I'll call it, 15 amp hours. These will be 15 amp hour packs, and I'll have 2 of them. So I'll have 30 amp hours at 14 something volts. Again, to make the voltage more usable, I'm going to use something like this thing. So this is an adjustable voltage supply, if you will. Right now I have it hooked to the steering battery just to kind of show you how it works. But when I turn this on, right, this now delivers 5.12 volts. And the nice thing about this is it's good for 4 amps. This Jetson Nano takes, they want it to have at least 2 amps, preferably 3. This is going to supply at 4 amps. So this is going to be the power supply for the Jetson. And I've noticed from playing with it so far, it's supposed to have 5 volts, but at 5 volts it kept browning out. So I moved up to 5.1 a little bit, and now this runs it very well. So these 2 battery packs over here are going to be in a metal box, and then the Jetson Nano is going to be, let me just put this as an insulator. The Jetson's going to sit on top of the metal box. Let me just swing around to that. Okay, so the Jetson's going to sit on top of this aluminum box right here, and then on the outside, oh, and then there's going to be, you know, just one of these switched power supplies in the box to keep it charged. There's going to be, you know, some multimeters around it. I'm going to put the same one I bought for the steering. I'm going to put on here as well. So this is going to measure the power going in and out of this, so I keep track of its battery. So it's going to take up, you know, and then there's going to be a relay in here. So if this battery pack starts going down too low, it's going to turn that relay off and turn the power off. And then I found this thing on the internet. This is kind of cool. So this is like I want a switch to turn this up to power onto this thing anyway. Like this switch here, I want to rely. This is only turning the 5 volts on. I want a switch to turn this whole entire pack on through this relay. So this has a switch built into it, 12-volt switch. It's going to give me the voltage. So I mean, I already have it on this display. I'm going to see what the voltage is. But hey, you know what? It's blue LED. It's another flashing light. So it's going to give me the voltage. But the nice thing about this kind of thing is it's got a couple of these ports up here, right? It's got USB chargers for anything you want a USB charger for. This Jetson Nano will run on USB if I want it to. It's going to be hardwired, but you know, I have, you know, 2 amps of power here, even just to charge my phone or a tablet that I have with me or something. And then it's got a lighter plug. So if I want to, you know, so many options, searchlights and stuff, you need lighter plugs for power. And again, this is going to be more kind of modular universal. I'll be able to use this lower battery pack for anything. I can take this off. I'll make it so this will come off easily. And then what I can do is, you know, use this as just a 12 volt, 5 volt, anything adjustable, 9 volt, whatever I want it to be, power supply, with switches and meters and all kinds of flashing lights, and I don't know, just to make it look cool. But then the next thing the next thing I have for this is this device. So this is a 360-degree rotating Lidar sensor. This is my treat to myself. This sensor is kind of expensive. I didn't want to spend this much money, but I decided that, you know, this passion or this hobby is not going away. I'm going to be part of this. You know, this is the new technology for vehicles, and I really want to know how it works. So this is not nearly the level that you put on a self-driving car. You know, I think this was $800 and something a sensor, which is a lot of money, but one that will reach out 150 meters in the rain and pick up a pedestrian on the sidewalk. Those are $25,000. So, you know, expensive for me, but you know, in the long run, you know, it's the cost of a night school course. So this is going to mount on some legs up on top, over top of this thing, so that it doesn't, the laser doesn't pick up things like, you know, antennas and stuff. I want this to be the highest thing on the vehicle. So it's going to sit up fairly high. And then beside it, which I don't have with me, but beside it is going to be a GPS antenna. So this cable is going to be input into the Jetson Nano. The GPS antenna will go into the Jetson Nano. Power from here will power the Jetson Nano. And then I have, on the side of this, there's HDMI and USB and all that kind of stuff here. So I'm probably going to put a small, like a 7-inch or a 8-inch capacitance touchscreen with this somehow. It'll mount, I don't know, on one side of it or something. Maybe I'll put all these gauges on one side and the touchscreen on the other, or have it on some sort of movable, I don't know, some movable platform up here, and that can plug into the HDMI and the USB for control. So this is what I'm working on now, is getting all the stuff. I'm building the box for this out in the garage, welding up an aluminum box for it, and then this will be, I don't know, there's a couple weeks work of building this. I'm looking forward to kind of using all these power converters and multimeters and building a very self-sustained robot control unit that maybe plugs into the other thing with. I found a really cool kind of military grade plug around my place, and I want to use that to plug this into the vehicle itself. So the speed controllers and the steering controller and that kind of stuff. So, building battery packs, building boxes, figuring out layouts and all that kind of stuff for all this stuff, and that's what we're working on now.